Good afternoon, everyone. My name is Mark Wong. I am a consultant with Second Quadrant. I've been a contributor to the Postgres community for, I don't know, over 10 years or so now in various aspects. I'm going to present to you a little bit about some business intelligence performance with Postgres, what performance has looked like over the years, what kind of changes have helped business intelligence type workloads, and what can really give the next big boost in performance. So how many folks here are heard of the TPC? TPCH benchmark? How many people love that TPCH benchmark? So for those who are not familiar, TPCH is a decision support benchmark that has a series of queries that you run that are supposed to represent questions that you want to ask, such as how much money am I making, which of my warehouses, or this is for a part supplier type business, which of my districts are making money, who is getting the most returns, and things like which sale promotions are helping my sales. So how many folks deal with those kind of queries, out of curiosity? So this is a little recap of basically 5 years of changes between 9.1 and 9.5 with, well, DBT3 is a fair use implementation of the TPCH benchmark, and what we're showing here is not really the benchmark as it's intended to be run, but the execution times for each of the 22 queries that this benchmark specifies and how fast they run. So these results are from a 32 core system with 64 gigs of RAM. These results represent a data set of 10 gigabytes. And the major versions along the bottom, 9.1, 9.2, and how much time it takes to just churn through all those queries one by one. So 9.1's taken about 700 seconds, and a little 10 minutes, and I think you can see that there's some gradual improvements over the years. But at the end of the day, after 9.5, we're looking at about 20% improvement, and we're talking about 20% improvement of a data set that's going to fit in memory. The type of changes that have gone in over the course of those major versions that are particularly relevant to these kind of workloads are related to efficiency improvements to how aggregates are calculated, like the sum and averages. The queries that are provided in this workload are using some number of sums and averages in each of these queries, and almost each of these queries are needing some sort of sorting done in the query plans. There have been improvements to how efficient hash joins are done, how well bitmap index scans are executed, improvements in, sorry, watching a fly, how locks are, how efficiently locks are sorry, I'm easily distracted. How easily locks are acquired and released in the database, and introduction of concurrent hash tables. But the query execution with a 10 gigabyte data set still takes minutes. How many folks here have data sets that are 10 gigabytes, give or take? And how happy you are with minutes in execution? No. So we'd like to claim or argue that it should be a lot faster than that, right? So now now the last couple of years of development work with 9.6 and 10 right around the corner, again with 10 gigabytes of data, you see a fairly huge jump here. We're looking at about a 3 times improvement. We're down to taking 2-3 minutes, 2.5 minutes to churn through 22 queries that are looking over 10 gigabytes of data. So that looks pretty good, right? People would be happy with 3 times performance. Well, better than none, right? Better than no improvement. So with 9.6, what really helped performance here was really the introduction of parallelization in the query plan execution. I have some of these items up here are jumbling some of the things that came in 9.6 and 10 together. Just to jump back here for a second, you see that big improvement going to 9.6, but it's not visually. You can't really see too much of an improvement going to 10, but the parallelization and doing the sequential scans and doing a number of joins and how aggregates are how the aggregation happens and bitmap heap scans and index scans. So those are what's this parallelism is helping us take a bigger step. And also, worth mentioning the multi-column optimizer statistics and the improvements in the expression evaluation that came into version 10. I mean, these are things that are going to help. You can't expect these little synthetic benchmarks to show everything, but these sort of things are still worth acknowledging as going to be helping someone. Now, how many folks here are dealing with hundreds of gigabytes of data? In this particular workload, moving up from 10 gigabytes to 100 gigabytes of data, where we only have 64 gigabytes of RAM, we're starting to introduce I/O utilization. The storage subsystem comes into play more here. Now we're looking at math. Hours, right? Almost 14. I wish I did this earlier in my head. Can someone help me do 14,000 seconds in minutes, hours? 3,600. 3.8. Thank you. So we're looking at hours of execution to churn through 22 queries now, when what took tens of minutes previously. How many people are satisfied with that? No one? No hands? And again, even at 100 gigabytes of data, it's still showing the same general trend between the 5 years of development between 9.1 and 9.5. You're looking at about 20% improvement. Then I think it's still roughly about 3 times improvement when the parallelism goes into play. But still, we're 100 gigabytes of data taking hours to query. So, just out of curiosity, how many people want to see that? People expect that to happen in minutes, seconds? Now, how many folks are reaching terabytes of data? Tens of terabytes? Anyone getting close to petabytes? Not yet? All right. So, these 5, 10, 20% jumps in improvement, they're nothing to be ashamed about. We should be happy we're making these kind of improvements. But now, how many people think that we should be able to expect 50% improvement? That at some point we should see a huge jump? No? Orders of magnitude? Or are you waiting for me to show you? Oh, okay, all right. So here's a chart that I'm showing the same sort of queries in a slightly different way, separating out the queries. This is a data set of 3 terabytes. Over on the left, blue colored columns. Are they showing up as blue? The light blue are the response times of Postgres on a 64 processor system, 128 gigabytes of memory, and an array of, I believe, 20 SSD drives. I may have some of these wrong, but I think I got it in the ballpark. So what we have in the purplish thing on the right is Postgres Excel. How many folks heard of Postgres Excel? I'll give a little more details about that in a little bit. But we have Postgres Excel running with comparable hardware. And what I mean by comparable is you got the same number of cores, logical processors, and same amount of total memory across 8 separate systems. So I think this shows across the board that well, I think you'll see a couple of some of the smaller queries. There's not as much of a difference, but you can see some of these huge days running long queries are significantly faster with Postgres Excel. And one thing that's probably worth mentioning is when we're talking about these synthetic TPCH benchmarks written at a time, how many folks were in Andres's presentation earlier? He was pointing out the making fun of the age of the benchmark, and I think when this was put together at a time where there weren't too many MPP style databases and whatnot, some of these queries may actually not be. Many folks here probably wouldn't be designing these schemas and queries to be, would have written them differently, design your database systems differently. So at this point I want to introduce Postgres Excel. Website up there on the top. I hope everyone takes a look and I encourage everyone to give it a try. It is a massively parallel database, meaning that it's horizontally scalable. You just add more systems for however big you need it to get. Folks familiar with StormDB, Postgres XC? This is a successor of that lineage of software development. So while I'm primarily focusing on what BI workloads look like, I just want to mention quickly that Postgres Excel certainly is fine for any OLTP needs also. So a couple other things to mention too is that with Postgres Excel, it is using a more liberal license, if that's a concern to folks, using the Postgres license than it has in the past or its predecessors had used. The current stable release of Postgres Excel is on 9.5. Right now, or just the other day, the project announced that it has released an Alpha 2 version against the Postgres 10 code base. So you will notice that it skipped 9.6. So, but now at 9.10, it's going to include all that with 10 being around the corner. The project is expecting to have a stable release out early in 2018. So just to talk about the Postgres Excel project a little bit more, while it is a fork of Postgres, it's not intended to take Postgres and run away with it, and wants to stay closely enough to the core project to be able to take advantage of when new releases come out. So when these new features like parallel query processing come into Postgres, that Postgres Excel can shortly come out. with a new version and also take advantage of these same features. So with 9.2, if I remember correctly, 9.2 was the first release of Excel anyway against the 9.2 code base. We're looking at almost 500,000 lines of code that had been added to Postgres in order to make Excel work. I'm sure you'll notice that there's a gap between 9.2 and 9.5. The project had basically kind of stalled until second quadrant had started to get involved in the 9.5 development cycle and helped get Excel rebased and in sync with the 9.5 code base. And in the meantime, even though there was no official 9.6 release, the developers had been actively working on keeping that code base up with 9.6 and wanted to show that they're doing what they can to keep that code base as close as they can through the 9.6 cycle, and then as they continue working as the Postgres 10 development is in progress. So, so the Excel code has been merged with Postgres 10 with the Alpha 2 release. They're currently claiming that there's no critical bugs, no known segmentation faults. Started out with about 80 regression tests failing and have whittled that down to about 15. So they're hoping to get a beta out soon. So as part of this merge, over 100,000 lines of code had to be merged. 15,000 lines of code had to be merged manually. So these guys are trying to work hard and get that code in there, or get things in sync and working smoothly. Now with the version 10 merge, how many folks are paying attention to what's coming in Postgres 10? So with that merge of the code, folks, when you're using Excel, you will be able to take advantage of the declarative table partitioning. You will be able to take advantage of all that additional parallelism that's in there now. How many folks have been excited about that logical replication? So even with Excel, you'll be able to take advantage of being a subscriber. So folks who are looking for logical replication to replicate their data to other systems for analytics or whatnot, I think Excel will be certainly an option that you could use for filling that need. And then the other great stuff that's going in Postgres 10 with new indexes, security improvements, other general performance improvements, and other new features like the security that scrams stuff and whatnot, right? And also with Excel, since it's fairly close to Postgres, you can expect other tools to work with it, such as Barman to do backup and recovery. Barman's another offering from second quadrant. And how many folks are using PG Admin? And the other one's escaping me. Oh, go ahead and shout it out. I'll try to repeat. Postico? Yeah, well, anyone who's needs to use a GUI graphical interface, they're nice to have. Help make your life easier, right? How many folks have heard of OmniDB? Yeah, so another offering that second quadrant's behind, and that will also be able to work with the nuances of Excel, and there'll be a lightning talk lined up today for that you can see more at. So I also wanted to mention a second quadrant commitment behind Excel. Two known Postgres developers have been dedicated full-time for over the past 6 months. Well, two for the past 6 months. We've had one person dedicated since the 9.5 merge. So Pavan Delavasi and Thomas Vondra are working hard in making Excel a usable product for everyone. And in addition to those two developers working on Excel, Second Quadrant is also dedicating some QA resources to do testing and making sure that there are no significant regressions in Excel. In addition to that, Second Quadrant is also supporting customers that are using Excel, customers with large multi-node clusters, data ranging all the way up into the tens of terabytes of data. So one in particular is the European Space Agency. How many folks are familiar with So the ESA is the European Space Program and do many interesting things with data from space, right? They in particular are using a 8-node cluster, 256 gigabytes of RAM on each node. They have an array of SSD storage and InfiniBand connectivity between each of these nodes, and they have over 20 terabytes of 20 terabytes of data. It's continually growing. Know that they're going to need to grow their cluster too, and are happy to be using Postgres to meet their scaling needs. Now, to talk more about the community around Excel, the ESA provides bug reports. There is a fairly large company in China called Tencent that is involved and has been active on the mailing list, providing patches and helping out with some of the development. How many folks are familiar with the Core Infrastructure Initiative? I think this is a program that the Linux Foundation is behind. While Second Quadrant is behind Postgres Excel, we certainly don't want to give the impression that we're the only company behind it, that it's our specific offering. There's an application in progress with Postgres Excel, and what this core infrastructure initiative is provide some guidelines on what constitutes a good open source project. They will give you a badge if you have your information available on the web. If you're using an open source license, which we are with the Postgres license, the source code repository is available publicly, and we have a bug reporting process. So they provide this little badge, and hopefully when we get through that application process, that we'll be able to display that proudly. So wanted to come back around to a little bit more performance data on Excel. We'll pull you for some questions here. So I got 3 terabytes of data. How long do you think it took to load 3 terabytes of data with Postgres on a single system with an array of SSD drives? Anyone want to shout out some guesses? Too long? Oh, 12 hours? Anyone want to venture days or weeks? No? Less than 12 hours? 18 hours? Yeah, so 12 hours to load 3 terabytes of data, and this does include building indexes, but yeah, 79 hours. So Yes, yes. So 3 terabytes of data that were, the question was this in parallel mode? And well, okay, it was loading text files across 8 tables simultaneously. Granted, the size of the tables are a little bit skewed, as one of those tables contains about 80% of that 3 terabytes of data. All right, so now who wants to make some guesses on 8 nodes? 8 nodes, SSD storage on each node. Same, but otherwise the data was loaded the same way. The data wasn't partitioned such that they went directly to 8 nodes. This 3 terabytes of data was just shoved in through and let Excel ship off the data to the appropriate nodes. Any guesses?
I'd like to see 8 or less.
8 or less hours or days? Yeah, hours. All right.
No, seriously. So
Yeah.
many places in many businesses, a 10x factor is the deciding purchase point. If you can beat a 10x improvement in performance, they'll buy it.
Now, in this particular comparison I'm making, I am comparing on comparable amount of resources. If I were to show 10x with twice the hardware, would they go?
Your mileage may vary.
Okay. All right. Any other guesses? One more guess. Not even for fun?
The first one was, same number of cores across X.
Yes.
Across Excel.
Yeah. So 64 cores across 8 nodes.
Okay.
Yeah, as opposed to 64 cores on a single node.
Think about a RAM across the cluster.
Right. So instead of, what did I say, 256 gigs on one node, it's spread out evenly across 8 nodes. 12 hours. All right. So over 5 times faster, not quite 10 times as I think I'm sure more than one of you were hoping. But then with a single node system, you can't, well, you only can throw in so much stuff into a single system, and I'm sure you could achieve much faster performance if you slapped on more nodes into that cluster. Yes.
So in this environment, or in the setup, is all the data going through one node and then being distributed to the rest of the Excel cluster?
Oh, yes. In this particular, the way I ran this particular test, the data is going through the one coordinator to get distributed to each of the nodes.
So it's just the networking bottleneck?
Good question. I don't know the answer to that, whether the network was the bottleneck in this case.
If you're going through a central coordinator, you're going to have significant load penalty getting into the coordinator.
So yeah, the way that this load test was run was, I mean, certainly not the best way to showcase Excel, but at the same time to show that it can still offer some big changes. So what I was hoping that everyone would take away from this is, with Postgres Excel, it's an option out there for you to get that next significant boost in performance with analytics and business intelligence workloads. And we expect folks to be needing that for terabytes of data. So with not showing where the limit really is, taking comparable resources, the parallelism that Excel provides across nodes, in addition to everything else that Postgres already gives you, you still can get an additional 5-6 times performance in loading data and querying.
Quick question, is it possible to migrate from Postgres to Postgres Excel? And if so, how long would it take to export, say, like 100 gigs from one to the other?
Also, the question is it possible to migrate over to Excel, and how long it would take to, say, do that with 100 gigabytes of data. So yeah, it certainly is able to migrate. You can move data into Excel just like you can move data between major versions of Postgres, and with tools like pgLogical and the built-in logical replication, you can use Excel as a subscriber to any other provider. Now, how fast it would take to move 100 gigabytes of data? Well, that's a little bit more open-ended. Oh. Oh, yeah. So, what Simon was pointing out was, you could use this as one data point of saying that, yeah, you should be able to load data in 5 times faster than you would be able to.
That's true.
But you have a couple options. Yes?
Does Postgres Excel perform index construction concurrently across the nodes?
Yes.
How much are the time savings from that? In parallel, so
Yeah.
how much of the time savings from parallel index construction?
Now, I don't really have any numbers for, well, I never looked at any of the index creation specifically, but, well, yeah. Yeah. Right. I think it's fair to expect a linear type of sorry, what's the word I'm looking for? If you got 2 nodes, you should be able to expect the index to be about twice as fast if the data is really split well.
So my question is, does Postgres Excel actually help with any kind of writing other than index creation? I mean, I can see it helping with reading. Does it help scale writes?
Oh, if Postgres Excel helps.
Spell everything right through a coordinator node, so like it would slow things down.
Yeah, right. So the question is, how well does Excel scale writes? And that will vary on how the writes are distributed across the nodes with the data. So, like, for example, if by some weird chance that everything that you're happening ended up going to one node, of course that'd be a worst case. And if the writes were able to be distributed well across the nodes, then while each individual system wouldn't be able to perform writes more than any other node, the capacity of writes that you could do would be that much greater with am I making sense?
Well, I mean, I guess I need to know, so the bottleneck would be the coordinator node, would it not? I mean, all the writes have to go through the coordinator? So
Mm.
just have the CPU and network to handle all of that? Or does Excel farm off clients to the individual nodes? Like the clients somehow reconnect to individual nodes that all go through the coordinator?
Yeah.
So you could, for example, run 4 coordinators over 8 nodes?
Yes.
Yeah, so to kind of paraphrase the concern about whether one coordinator is getting overloaded with writes, or if you don't mind me rephrasing it that way. But one thing about these numbers I am throwing up, I am running a pretty simple, there's one coordinator handling eight nodes, and you could help distribute the load that a coordinator may take on by having multiple coordinators set up across the cluster and well, working together.
Is that transparent to the client, or to the client is multiple nodes?
That part I sort of forgot. I mean, obviously, I think you can put a load balancer in front of them, obviously, but I can't remember if the coordinators will, if you have more than one coordinator, if one coordinator, well, if you have to yourself balance your load across coordinators, or if the coordinators do any of that for you. Okay, yeah. So I think you do have to do your own load balancing in front of the coordinators, but then from each coordinator, it will still look like a single system. And with that, the other thing I wanted to leave you with is that Postgres Excel has the full backing of second quadrant. We will stand behind it with our 24/7 support. Please don't hesitate to come talk to us more at the booth in the booth upstairs, or send us an email. Are there any other questions? All right, thank you, everyone.